Hello students, question number 46 is from test series 3, subject strength of materials and chapter torsion, and it is of 2 marks. The question says, a composite shaft consists of solid brass core of G is equal to 40 gigapascal with outside diameter of 40 mm covered by steel with rigidity modulus 80 gigapascal tube with inside diameter of 40 mm and a wall thickness of 200 mm. Both materials are bonded so that they act as a unit. Find angle of twist in a 3 meter length when the assembly is transmitting a torque of 10 kilonewton meter. Option A 0.04815 radians, option B 0.0963 radians, option C 0.1926 radians, and option D data insufficient. Now, the brass core of 40 mm diameter is covered with a steel with thickness of 20 mm. The torque of the assembly is 10 kilonewton meter. We have to find the angle of twist in the assembly. The length of this assembly is 3 meters. So, given diameter of the brass is 40 mm, therefore thickness is 20 mm. So, diameter of the steel will be 80 mm. The rigidity modulus of both brass and steel are given, and the torque and length are given. We have to find the angle of twist in the composite shaft. Now, let brass and steel carry torques TB and TS respectively. So, both TB and TS will sum to the total torque of the assembly, which will be 10 kilonewton meter. So, TB plus TS will be 10 into 10 power 6 Newton mm. Let's take this as equation 1. Now, as it is a composite shaft, the angle of twist in the brass will be equal to the angle of twist in the steel sections. Now, using this formula, that is T by J is equal to G theta by L, we can find the angle of twist. Now, substituting this for both brass and the steel sections, we will get the equation that is 30 TB is equal to TS. Let's take this as equation 2. Now, solving equation 1 and equation 2, we'll find the values of torques in both brass and steel as this one in terms of Newton mm. Now, angle of twist, that is theta, will be equal to the angle of twist TB and TS. So, theta will be TL by JG. Now, considering only the brass section, by substituting all these formulas, we will calculate that the angle of twist is 0.0963 radians. And this is our final answer, which is option B. Thank you.